Example 6, section 2.1. This example will give the importance of wording. We're going to be looking at repetition versus no repetition. A luggage lock opens with the correct 3-digit code. Each wheel rotates through the digits 0 to 9. So first of all, I want to talk about the digits 0 to 9. When we look at the number of possibilities, don't forget that we have the numbers 1 through 9 plus the digit 0. So when we talk about digits 0 to 9, there are 10 digits, not 9, that we can choose from. So part A, how many different 3-digit codes are possible if repetition is allowed? Okay, so we have 3 positions in our 3-digit code to consider. In this first digit, there are 10 choices. Repetition is allowed, so that means whatever digit is chosen to go in that first place, it's independent of what goes in the second. That number that was chosen in the first place could also go in the second place and could possibly go in the third. So in this particular question, there are 10 choices for each of those 3-digit code. Using our fundamental counting principle, multiply the number of possibility for each. So there are 10,000 outcomes. Part B, again, the same question, but this time, suppose each digit can be used only once in a code. Only once. How many different codes are possible when repetition is not allowed? So again, we have a 3-digit code. We can choose to place a number from those 10 digits. We can choose one of those 10s to be placed in that first position. But in this example now, where repetition is not allowed, whatever number goes in that first place, it cannot go in the second place or the third. So we fill this position first, which means now there are only 9 remaining digits to choose from to place in the second position. And same reasoning, there are now 8 numbers to choose from to place in the third. Again, multiplying the number of choices together for our fundamental counting principle, we end up with 720 possibilities. Notice that when repetition is not allowed, there are less choices, of course.